Hello, in this video we will be looking at the engine class, which is obviously the heart of the whole game. And maybe best first to look at the class chart which I have created. I'm not sure if this is perfect currently, but let's see. So this is the view class, which is the MFC view class, which is over here. So this is the where the Windows messages are happening, like the mouse moves, and where we draw the actual class which draws the window. And then this view class is connected with this MFC handler class, which we will be looking at later on. So this MFC handler class is one of those which this game library we have to create when we have a new platform. This is the kind of class we have to create. So for example, when we have a console program instead of Windows program, in that case this class will be a console class, and we will need to create a corresponding console handler class. And so in this project, or if we go to Linux, we have another graphical system. But the thing is that in all of these systems, there are three classes we need to overwrite or write again. So this class, and this class. We will be looking at these classes in details later on, but I'm just saying it now. So all the other classes are general classes, and we are just inheriting our classes from them, like here and here. But these are the only three classes we need to recode when we have a new graphical system, or we want to port this code to somewhere else. Okay, so this view has two things here. It has the engine, which is gonna do all the calculations and moving the pieces on a board, and it's doing all the action. This MFC handler class, its responsibility is to handle all the messages from the Windows, and like mouse move, left mouse button click, and all the other things as well. And also it's gonna handle the drawing initially. It's gonna start the drawing, handling the drawing message, and so on. And the other thing we have, so the engine is here. So the engine is here, and the engine has the board. It has the board in it. It's a member of this class. And then another thing here is that so this MFC handler is inherited from this render class. So render class is it's a rendering. It's a virtual. It's actually a pure virtual class. Let me double check that, because I don't remember everything always. So I think it was a pure virtual class. Let's see that. And there we go. Because it has one pure virtual function here, that means that it is a pure virtual class. So we can't create an instance of render. We have to inherit a class and make an instance of that. That's what it means. And all of these functions needs to be written in the inherited classes. Have to be defined. The classes which are inherited from which are derived from render class. And then we go back here, and so this MFC handler is using this variable. These are small classes. It's using these classes when it's sending messages. But we will go go and see them in detail later on. So these are minor classes here. And then we have this board which we already have been looking in the last video. This is the class board class. And one more thing is here that when we are setting the parameters for engine, the engine will give its pointer to the renderer. Why is that? The reason is that so that when we are drawing something, it can take information from the engine, for example the board information. When we are drawing something, the renderer can get access to the data of the game. That's why we are sending, when we are setting the parameters, we are also sending, or should I say saving. It's here, it's this one, the engine pointer to the engine. So this renderer can get access to the engine and all of its data. Okay, we are not going to go to the details right now, but just a general overview so that we can now start looking at this engine, because it uses this renderer here, by the way. So a little bit understanding about this structure now. So let's start this this engine class, and analyzing what we have here. First of all, we have only private and publics, which is a good thing. I think no protected it's not good to have protected members. That's the object-oriented principle normally. So the first one here is the game state. I already talked about this before, that we have 2 states at the moment. Obviously in the future there can be more states, but at the moment we have only ready to start, and the other one was, let's go and see, the other one was game over. So obviously when we start the game, or when we start a new engine, it's good to initialize it straight away here to ready to start, that the state is ready to start. We are ready to start the game. The next one is game over information. So this is used only after the game is finished. We want to ask information about the last position, like for example if it's a winner, we want to know that which direction is the win and who won and so on. So this holds that data. And here we have the board. This is very important here. It's keeping the data about the board. We already have studied this board in the last video. So let's go back here. So this one is now whose turn is next, and we will initialize it to this constant variable which is defined here. This one, player to start the game. The player to start the game. Maybe we could say player to start the game, but obviously this is a game, so player to start. So in this case, for example, Cross starts the game. So we can easily change it because it's a variable now here. So changing this one here, it goes all the way to here and here. Then we have the winning row length. So this is the variable which holds the number, that how many pieces needs to be in a row that it's considered a winner. Do I need to show this? I guess it's good to show. For example here. So it's obviously it's this one. So if this is 2 here, if we put here 2, oops, not 22 but 2, we put 2, that would mean that there is already a winner here. Cross has a winner here. That's what it means. I think we could start with 3. Well, we're gonna set it later on, but just in case, put some reasonable value there. And the last one, we have the move history. So we will save all the coordinates of each move. We will save the history of the moves. So it's handy then we can print them nicely somewhere. So let's go and look at the functions what we have here, and first we have this getBoard function which returns the board, and let's go and see actually where it is. It's getBoard, it's here. So this getBoard it returns a reference, constant reference to the board, meaning that we can't change this board. We can ask values from it, but we can't change any of it. We can't change its size, we can't change its content, but we can ask its content. And the const means that we are not going to change any of these data here. We are promising not to change any of this data here. The next one will be here game state. It will return the current game state, this one. Next one is game over information. It will return the game over information, which is here. It will return a copy of it actually. And the next one is get move history. Let's go here. It's this one. And it will return a constant reference to this move history array, vector. So basically we can ask values without making a copy. Obviously, depending how we call this function, it can also make a copy of it depending how we call this function. And const everywhere here, meaning that none of this with all of these functions we promise that we are not going to change any data of this object, these ones. What else we have here? We have this get win row length, obviously just a get function to get this private member, the winner length. And let's go and see the more complex functions next. So we go to engine CPP, and we will first maybe look at the set parameter function. So set parameter, so when we are creating engine, we want to set the parameters for the engine. So the purpose of this function is set all the parameters of this game actually, and this function can forward them to other objects then if needed. So the first parameter is the renderer. As I said here, it's because of this one here. We want to send to this renderer, we want to send the pointer to this engine. We are doing it right here. So we are saying that renderer, its engine has an address of this engine object. So this engine will be pointing. This variable will be pointing to the engine. So this renderer can always contact this engine object via this pointer. And one thing I would like to show right away here is that if we go and see the engine, the renderer class, which is here, we can see that I have set here it's a friend. So this function here, this engine parameters class, this function here, only this function is a friend of this renderer class, meaning that it means that this function can get access to the private members of this class, because this engine here is a private member. So I'm only letting this function to get access to this variable and able to set it as well, like we are doing here. And then here we have rows, obviously the rows of how many rows this board will have, like here 6 rows. And columns, how many columns we have. Here we have 4 columns. And win row length, so here here we are defining how many pieces in a row will be the winner, and we will just save it here. And let's look at the next function, for example this new game. So new game is doing what it's saying. It initializes a new game. It doesn't really start, but it just initializes everything, that everything is ready. This engine is ready for the new game. That's what it's doing. And so first thing we're gonna do, that we're gonna set the game state to ready to start, and we will, just in case, we will set the winner to be empty. How we define this thing is that this winner, if it's empty, it means that it's a draw at the moment. It's draw, meaning nobody won. If it's, you can also have values cross or not, and obviously it means that the cross won or not won. So at the moment nobody is winning, so empty. And this empty is gonna, we already gone through this function in the last video, and this empty will empty the board. It will set each square to this one. The move history, we will clear the move history vector, as we can see from the tip window here, that it's a vector, and clear will make it 0 size, make the size to 0, and we will set the next turn to be next turn to be X. Okay, this one I want to check actually. It's a little bit confusing why it's X here. I want to check this one here now. Engine. It's here next turn. So what if I put here that next turn is not, because I don't remember is it gonna follow this one or not. So let's run this game, and no, it doesn't follow this, and let me see the reason why it's not following that. Find all references. And if we go here, new game, new game, I think now it would follow it, so according to my theory. So now here it follows. In this window it follows. And what is the reason? What was the reason again for this? And I can actually see the problem. There's a small mistake here, because I'm starting a new game for this first game. This is the first game here, and this is the second game. So there should be 2 here as well. Okay, there's a small issue here. I didn't call the new game for this second. So if I compile it now, so both should start with not actually now. And that's how it goes. So now it's doing like, but obviously, so this one determines that who is actually starting. But we don't actually want to set it like this. We actually want to do exactly what we were doing here. This one. So this is defined as a const at the moment in the definitions. So now it should use the default value of this, which is at the moment the cross. Okay, and then next we have or maybe maybe I will have a break here and I will start a new video, because this is a little bit longer. It's gonna be a little bit longer here, because we have the next move and then we have the winner check here, which is gonna be a long function here. We're checking the winner. This is gonna be a long function, and it has one nice lambda also here. So thank you for watching, and we will start a new video to continue this class.